Terraform is dead, long live Kubernetes API. This is the question, not the statement.
Yes, yes, yes. Don't hit.
At least right now. Okay, let's see if this is true or not. Michał.
Thanks. So, like you see, Terraform is dead, long live Kubernetes API. And there is a question mark at the end, so don't hit yet. Quite controversial, don't you think? So, in this lecture, I try to show how we can define a new way how we can manage the infrastructure and give more free will to the developers to not be some dependencies on our DevOps, but DevOps should give them tools to make some infrastructure by them. So how looks like the typical deployment of the application? We have happy developer who creates some commit to the code, to the repository, then there is some pipeline which build the application or the container, test it, push to the artifact repository or the container repository, do some scans, and deploy on environment. And that part is closed in the CI/CD pipeline in most cases, and as the artifact deployment is done on the today in most cases in the cloud or the other places. But the situation is a bit more complicated when our application is evolved and requires some new stuff from the infrastructure, bucket, database, whatever you want. So again, we have our happy developer, but he requires now some additional stuff. For example, we can stay with the bucket. So we have two options how to do that. One option is ask not very happy DevOps to provide this bucket for him. So the DevOps need to get the request, Jira ticket, whatever is it, write some code or update some code, use tools, and at the end, we have in the cloud our additional piece of the infrastructure. Or if our developer is quite ambitious and don't want to involve the DevOps and have knowledge, he can skip the DevOps guy and do this by himself, and then do with his stuff. Today, in most cases, the development is done of infrastructure. The development of infrastructure is done with the Terraform. And how Terraform looks like. So we have the manifest. We have some CI/CD. We need to do Terraform init, plan, apply, and then we get our piece of the infrastructure. This is most common, most of us using this, and I try to focus on plain Terraform because I know we have now many additional tools like the TerraGround, Spacelift, etc. But I focus only on the Terraform. So this approach with the Terraform have pros and cons. What pros have Terraform? Terraform is commonly known. It is already a couple of years on the market, have quite big community, is very popular. So we have plenty of the providers. That's why it's commonly used. The most big companies start using the Terraform. They migrate there. So yeah, it's very popular. But also Terraform has a minus. One of them is the HCL. So this is the domain-specific language created from the HashiCorp, dedicated to the Terraform or other projects of the HashiCorp. So if you want to deploy something with the Terraform, we need to know HCL. Terraform don't have any API. So we have only file manifest, run the binary, get the output in the state file. That's all. We cannot check anything ad hoc with the Terraform. We can go to the state file and check the file and have hope that the same file is on the cloud, or simply go to the cloud and check how infrastructure looks like. When our infrastructure is growing and is getting bigger, and if we don't have good managed the state file, Terraform can start running. Execution of the Terraform can take longer and longer. So if we have project with rapid development, when there is constantly changing, infrastructure can constantly change, our deployment can take more and more time. Terraform also is not state aware. Like I mentioned already, we have the state file, which represent the infrastructure, but no one checking this. Terraform only is aware that anything is changed when we go through this cycle one more time. So we init, plan, and then we have the information what will be changed. And if someone goes to the cloud or change anything manually, we are not aware of that. So we can broke someone's work, or he can broke our work. And some recent problems. So who guys from OpenTofu mentioned licensing. Terraform, future of the Terraform with the license is unknown, so we don't know in which way which go. So how to live with that? There is alternative. The solution is the crossplane. Crossplane help with a couple of problems which I mentioned about the Terraform. The first of is using the Kubernetes. So most developers know Kubernetes, developers know how to write some basic manifests for the Kubernetes. So for them, it will be easier to manage the infrastructure in the same way, because they use the same language, like the YAML, use the kubectl to deploy new infrastructure. We can easily manage this with the Argo CD to get piece of the infrastructure what is needed for all cloud providers. There is, of course, there is not only the cloud providers, there is more of them, but I will focus on that. How this mechanism, how crossplane is also fixing the issue with the state awareness, and how it's doing this. It's doing this by the reconciliation loop, which is the mechanism already implemented in the Kubernetes, and has how this mechanism works. So we have the controller. It doesn't matter. It can be kube controller for the deployments or something like that. And we have our manifest, desired state and the current state. So when we have our file, this is the desired state. When we apply kubectl, apply our manifest, we have the current state. And current state can change, but it will be always going to the desired state. And for that, there is the control loop. Controller is always checking periodically to checking the desired state and the current state, and try to move the current state to the desired state. And that's in that way, the crossplane helps to keep our infrastructure in the way what we want to have. And so we go to the demo, because I think the presentation will be the best one. To support my work, I have prepared the Argo CD and some manifests. So we can start with the installation of the crossplane, which should be quite easy, because we can use only one Helm chart to install it. It shouldn't take long. Yep. Workloads. Yes, crossplane is almost installed. But except of the crossplane, we also need to have provider, because my example will be focused on the GCP, so I need to GCP provider. And cross-plane configuration. So to do that, I start with this file. This file describes the service account which needs to be used and the deployment runtime config. In that config, I say I want to use this service account in the deployment of the crossplane. And now what I do, I create the provider for the particular cloud. kubectl. And what this is doing? So if we go to the crossplane, these two represent the basic crossplane configuration. They create the CRDs for us to manage the crossplane. And now I create the provider. There is GCP Cloud Platform and GCP Storage and Unbound Provider Family GCP. I create two providers, but I have three related to the GCP. Why? So the Unbound go with the idea that do not create one provider for all resources from the GCP, to not create too many CRDs for the inside the Kubernetes. Instead, we have dedicated provider. For example, we have the dedicated provider for the storage, and this one only creates the CRD related with the storage. Cloud platform create only CRDs related with the cloud platform. So now we have the provider, we have the service account. Now at the last step, we need to config to handle the GCP. I use the workload identity functionality of the GCP to handle that. So now I deploy this kubectl apply config, and we have all our pieces in place, so we can go further. So for the presentation, I prepare some basic application which will be using the bucket. To start this, I need to apply the Argo CD manifest. Manifest is created, so we can go to the Argo and check if something shows up. Yes. So this is our basic application. The code of the application looks that way. Like we have the application, and application creates some echo. So we can check in the logs. Yes, everything is working. So, but now our application, we want to update our application to start using the bucket to write something to the bucket or read something from the bucket. So which steps we need to do from the perspective of the developer? So we have the GitOps in the place. So we need some additional stuff. The first one is the service account, because our application needs a service account to connect to the GCP services. So we can uncomment this. Push the changes to the repository. Go back to the Argo and refresh. Argo fetched the changes automatically, but to make this process a little bit faster, I synchronize this. So it should fetch changes instantly. The problems of the demo is always that something can broke up, so yeah. I'm forwarding the port, so and you see that we have service account, and this service account is created inside the GCP. So when I go to the GCP, go to the IAM, service account, GitOps bucket sh. So I have service account is GitOps bucket sh is values for the Helm, which describe the service account. So everything is working. Is created our service account, and that was very easy. I simply uncomment the code, put a couple of the values, and everything's in the place, and everyone can do that. So the next step, I want to have bucket to change my code to start using the bucket. So one more time, I go to this chart repository, chart file, uncomment the code, and I have the definition of the bucket here, and have some values. The name of the bucket, the location, storage class, deletion policy. I can add some annotation labels, and IAM, which stands for that. Okay, I want to give access to this bucket for this service account with this role. And again, I commit the changes, push them to the repository. Go to the Argo. And like you see, we have already the new object here, which represent the bucket. And for now, the bucket is not yet ready because in now crossplane using its API, connecting to the GCP and trying to create the bucket, but it shouldn't take more than a couple of seconds. Also, is also create the IAM role, which will be used to send the data. Like you see, the IAM role is created, but in the message says that gave error because the bucket is not created yet. Close storage. Okay, it takes, it needs a little bit more time. Of course, we can check everything from the perspective of the Kubernetes, so kubectl, get buckets. And as you see, we have the status, it's ready, it's synced. So it should be the true. So when we go back, yes, we have the new bucket. For now, is empty. But we want to save something in that bucket, so we back to our application. I comment this. And comment this. refresh to check is Argo quickly fake the changes. We have the new application which will be sending data to the bucket. And we can check that simply by refreshing. Yeah, we have the new file application create everything like a charm. So creating the new piece of the infrastructure was very easy. Of course, it requires some preparation from the perspective of the DevOps or the platform engineering, because this whole approach is in it simply for the platform engineering. It can be taken as a base for the platform engineering, so we can provide some platform for the developers. They simply use Helm charts as the dependencies and create the infrastructure. So we can handle this in that way. Okay. So Terraform is that long-lived Kubernetes API. So Terraform for sure is not dead yet, and I don't know if it will be dead. I'm quite sure it takes very, very long time to that happen, because last time when I checked, Terraform consumed about 90% of the market for the infrastructure as a code. But still, we have the alternative in way of the cross-plane. And when I use the cross-plane, first, for sure, for the new projects. When I have the new project focused on the application, and I have 100% sure that the project use the Kubernetes, and developers want to have more power to create stuff by themselves and faster the development, yes, I will go for the cross-plane for sure. So when Terraform, like you see, to manage the infrastructure with the cross-plane, we require the Kubernetes. So there can be the question, what should be, there is the problem, eggs and chicken. What is first? So we need to Kubernetes have first to start using the cross-plane. So Terraform can be used to create a Kubernetes cluster, but don't necessarily, it's not need to be Terraform. There is the cluster API from the CNCF, which also support that kind of stuff. And what next? Terraform is, like I mentioned, is commonly used, consume about 90% of the market. So in the projects which already use the Terraform, it's very hard to migrate to the new solution. So probably it takes time. The other problem is the business itself. Big companies don't like rapid changes. They prefer stable development. So if already they adopted Terraform, they will stick with it as long as possible. So yes, Terraform for sure is not that, and like in short term is don't be that. Okay, so I think we can open the discussion. Any questions?